Welcome to Algebra 2. This is Unit 1, Lesson 3. I did not change the numbering convention from last year, so it says 1.3, but that's Unit 1, Lesson 3. So this video is for students that are either absent in class and need to make up the lesson, or are present in class, but you need a refresher or you need to just go over the material again. So this lesson has to do with linear functions and analyzing real life situations with those functions. So we are going to be looking at writing linear functions, comparing them to solve real life problems, and determining the line of best fit. So that's what's in this particular video. So I wanted to start by writing the equation of a line. Now, this is a skill that should be covered in Algebra 1. So it's one of those skills that in theory, I'd love for you to already have, but I know that Algebra 1 is really rusty. So what we're going to do is walk through this. We're going to create a sketch first, and then I'm going to give you my preferred way of doing this. Now, there's other ways to do this. So if you go onto the interwebs and you just say write the equation of a line given 2 points, you will probably get some other methods. There's the point slope form of equation of a line. There's a lot of ways you could do it. I'm going to give you the method I prefer. You are welcome to use other methods. Just whatever method you're using, make sure it's a method that you understand. So the first thing I want to do is just create a sketch here. We want to begin in math utilizing different ways of representing problems, okay? And so 2, 3, 4, 5, and 1, 2, 3, 4. And so what I mean by that is you can manipulate the number part or the equation part, but in a lot of cases you can also graph it. You can look at it, and for a lot of us there'll be something that's obvious when we look at it that maybe isn't obvious when we are just manipulating the equation, and we can use that to check our work. So what I'm going to do here is I'm going to actually plot these 2 points. So I've got the point -2, 2, so I go left 2 and up 2. So my line is going to go through that point right there, and then it's the point 4, 5. So I go to the right 4 and up 5, and I think that's how many I counted. So about here. Now I am doing this on a computer screen with a mouse, so it's really less than ideal. If you had a piece of graph paper, you could do this much better. But what that does for me is it gives me an idea of some of the things about this line. So first of all, because the line is tilting upward as I go from left to right, I know that my slope should be positive. So if I go and do my slope calculation and I don't get a positive number, then I know that I've done something wrong, because I can tell from this graph this slope should be positive. Now I could actually get the slope from the graph, and I can show you guys how to do that as well. So if you're not comfortable with that slope formula, if it makes you uncomfortable with the minus signs and stuff, if you can use the graph, you have another tool at your disposal for getting it. The other thing I can see is the y-intercept. So now this is a super shaky graph here, but I can tell that the y-intercept, it's greater than 2. I'm not sure I'm willing to commit that it's less than 3, just because if you look at how low my line is, down here, it's at the bottom of the point. I have a feeling it could be shifted up, but it should be greater than 2. It's not going to be as high as 5. So my y-intercept should be somewhere between 2 and 5, and I think it's going to be closer to the 2 than it is to the 5. I don't want to draw too many conclusions from that. But what I do know is that when I get my equation, if I end up with a y-intercept of -4, it's wrong. I've done something wrong. So by sketching it, we do get an idea of what our solution should look like. So to find the slope, we use this formula. The slope is equal to y2 minus y1 over x2 minus x1. So I hope that is a familiar formula to you. That is an x2. It looks a little dodgy, and the screen is super small for me, so it's hard to write on. The 1 and the 2 there, are what are called subscripts. Okay, sub means below, script means writing. So a subscript is writing that is below. And the only reason we have those subscripts is so that we can separate one point from the other. So you've got like 0.1 and 0.2. You might have seen that formula y1 minus y2 over x1 minus x2. That's because it doesn't matter which point is 0.1 and which point is 0.2. As long as you keep them separate. So once you decide like this is going to be 0.1, negative 2, 2, then you got to commit to that. Okay, so we'll go ahead and we'll plug that in. And I'm going to go ahead and I'm going to call, I guess, this 0.1. I'm putting like a little 1 there, and we'll make this 0.2, but you could do it differently. So y2 would be 5 minus y1, which is 2, over x2, which is 4, minus x1, which is negative 2. Now that, like, we're going to stop for a hot second right there. There is a minus sign in the formula. Okay, everybody observe, minus sign in the formula. You will also have a minus sign that comes in with the negative 2. So in my denominator, I have 4 minus. This minus is the one that comes with the formula, and then this minus is the one that is coming in with the number itself. Most of us do not like that, and so we would prefer to write that as 5 minus 2 over 4 plus 2. Okay, so minus a negative would be the same as adding. 5 minus 2 is 3, and 4 plus 2 is 6. And then 3 over 6 simplifies to 1/2. So hopefully you can see that. I have said all of it out loud. Once in a while, I will get a student who will say, I couldn't follow what you did. And I just made that super messy. Let's see if we can clean that up. I was trying to clean up the 2 a little bit. And they'll say to me, I couldn't follow what you did. And I do understand that the writing on these slides can get messy, especially if I'm doing it really small. However, what is often the case when that happens is that the student has it on mute, which I understand. I don't really want to listen to myself either, but they've got it on mute, and so they're not listening, because if you're listening, you should be able to say, okay, 4 plus 2, because I said it when I wrote it. So make sure that it's not muted. Now, remember I said when I looked at this, I knew that the slope should be positive. I have positive 1/2, and so I'm fairly confident. Now, if you're not confident in the slope formula and you're able to do this, you can actually find the slope using rise over run. So it's how far you go up divided by how far you go over. It's like up and over. So to get from one point to the other, I would go up 1, 2, 3. So I went up 3 units. And then I'm going to go across 1, 2, 3, 4, 5, 6. So my rise is 3. And my run is 6, which will simplify to 1/2. So there's not like one of those ways that's better than the other. Those are both totally valid ways to find the slope of that line. The reason why we don't always count is because if you've got numbers that say have decimals, or you've got numbers that are really big, like they're in the thousands, you're not going to be able to count that at least efficiently. And so the formula is something that will work even when you have awful numbers. The counting is really only good if it's small or you've got an efficient way to count it. Now, in order to write the equation for a line, I maybe should have put this up here first. We need to know the slope and we need to know the y-intercept. I mentioned it at the beginning. We now have the slope. So I'm going to have y equals, and now I know that the slope is 1/2. The problem is I don't know the y-intercept. Now, there's a lot of ways that you can like arrive at that y-intercept. Here's what I like. I like to do what I call borrow a point. So I've got these 2 points. I got negative 2, 2, and I have 4, 5. I can use those for an x and a y. I mean, we use them for an x and a y right here. You know, we have y was what, 5 and x was 4 that goes with it. So what I like to do is I like to borrow an x and a y. So, and I'm going to pick the 4 or 5 because 4 or 5 is positive, but you could pick 2, -2. So if you're watching this at home, you're like, I want to be a daredevil, I'm going to pick the other point. Okay, I'm going to pick -2, 2. You can do that. It'll work just fine. So in this case, the y is 5. The x is 4. And now you might notice that the only thing in this equation that I don't know is the b. 5 equals 1/2 of 4 is 2. And now I can solve that for b by subtracting 2 from both sides. So I end up with, I'm going to move over above my head here, 3 is equal to b. And so now I know my y-intercept. And if I come back over here, that's reasonable. Okay. And remember I said earlier, like my line was a little bit low. And so a y-intercept of 3 is a reasonable answer. If it were way up here, I'd say nope, not reasonable. If it were way down here in the negatives, nope, not reasonable. But 3 is reasonable. Now, notice what the directions say here. I'm going to turn on the highlighter and like highlight the directions. Write the equation. I don't actually have an equation written here. So if I would like to write the equation, it is going to take the form y equals mx plus b. Now, remember I said the 4, 5, I was only borrowing it. Okay, if you come into class, you say, Ms. Taylor, can I borrow a pencil? Sure, borrow a pencil. I give you the pencil, and at the end of the class period, you should give it back. So we borrowed the 4 and the 5 for the purpose of finding the b value. But once we have that, oh, that does not show up, does it? There we go. Try again. Once we have that, we can go ahead and write our equation. We're going to give back the x and the y, and we're going to keep the slope y equals 1/2. We're going to give back that 4 and go back to the x. And now I know what the b value is. The b value is 3, and there's my equation. So there's the equation of the line that goes through the points -2, 2, and 4, 5. Now, I was on this slide for like almost 12 minutes because I wanted to go through that in depth. I wanted to go through it in detail. I didn't want to assume everybody remembered it. So if you need to pause it, if you need to take another look at this, if you need to rewind it, it's only going to take you about 10 minutes to rewind it and just work through that process again and work through that explanation again. Down in the lower left, you can see that there is a link for another video with some detailed instruction in it. So that's an earlier video. If you really want to go through this in a video where the only thing that we're going over is how to write the equation for a line, that video link should do it. I'll see if I can remember to link it in our Teams channel. If you want it and I don't have it linked, just say, Ms. Taylor, can you go and link that video? It's on one of my other playlists. Okay, I'd be more than happy to do that for you. All right, so this next part is just practice. So in your notebook, in your notes, work out the equations for the lines below. Check your work with Desmos, so you can go ahead and throw it into Desmos and look at it. Be prepared to share your work with the class. If you're making this up at home, okay, then what I can do, I guess I can pause the video, I can work out the equations and you can just check them. But I do want you to pause the video at this point and take the time to work it out on your own and then unpause it when you want the answer to the problem, okay? So I'll see you back here in a few moments if you're going to be pausing the video. Aha, we're back. Good. Okay, so I worked them out on a little side piece of paper, and this is what I got. For the first one, I actually made 2 sign errors. It's still early in the school year, so apparently not on my game yet. Y equals -3x minus 2. And then this one actually is simpler because you're given the slope of 1/2. So that whole first part where you're finding the slope, like you don't even need to do it. You can just jump right to the second part. And this one I got y equals 1/2 x plus 3. Okay, now what I want you to do if you're doing this from home, okay, and you, first of all, if you did not get the same answer as me, double check your work first, okay, double check and just see if you can find, like, if you got the -3 for the -3x, but then you got -8 instead of -2, probably that's a sign error in your operations, like you subtracted when you should have added. And you can probably find that if your work is structured well. You can kind of go down and see, ooh, I see, like, now that I know I'm supposed to have a -2, I see what I did. If you can't find your mistake, what I want you to do is this: take a picture of your work and either post it on Teams with your question, like, Miss Taylor, can you find my mistake? Or send me an email. If you don't want to post it on Teams where other people can see it, that's totally fine. Send me an email with the photograph of your work, especially if you think I did it wrong. Like, if you're going over it like a bunch of times and you're like, Miss Taylor, I think you added, 3 when you should have subtracted 3. Like, please let me know. I don't want a mistake to stand there. So let me know and get in touch with me that way. Otherwise, like in class, we're going to go over these in class and we'll go over the work for them. Okay, so this is where I think math gets interesting and fun. For me personally, and I mentioned like the first day of school, I have a degree in engineering. I don't necessarily love math because like math, like yay math. I like math for what it does. I like to see how it applies. I like to see how what I'm doing in a problem corresponds to something outside of just X's and Y's. Now, I don't even have to be the one to use it. I just like to know that it's useful and to get a sense of how it might be useful. So the graph shows the remaining balance, Y, on a car loan after making X monthly payments. Always pay attention to your vocabulary. If you are having an issue understanding a problem, it might be like a vocab. What do I have going on there? I have like a white highlighter, so that is useless. So you kind of need to know what balance is. Balance is the amount of money that you still owe. So if you're going to buy a car and you take out a loan, is this a car loan? Car loan, yep. So if you're going to buy a car, you might need to take out a loan. Okay. And so the bank loans you some money. And then what you need to do is you need to pay back that loan. As you do that, the amount of money you owe is going to go down. That amount is called your balance. Now, when they say balance Y, what that means is that balance is going to go on the Y axis. So the numbers that you're looking at on your Y axis here is how much money you owe, and it's in thousands of dollars. So this number right here where it says 18 means you owe $18,000. When you get down here, it means you owe $0. This number here, you owe $6,000. Every month you're making a payment, and you'll notice it says X. So on the X-axis is the number of payments. So the way you could interpret this is after 30 payments, you owe, like, what would be like exactly halfway between 6 and 12, like 9. So $9,000. So after 30 payments, you owe $9,000. And that's how you interpret what the points mean after this many. So the first question there is write an equation of the line and then interpret the slope and the y-intercept. And then I think looking at the notes outline handout that I have for class, I think I just said interpret the slope and the y-intercept and what is the balance after 36 payments. So first thing we're asked to do is write the equation of the line. Now, we can actually take some shortcuts here. In order to write the equation of a line, remember that we need the slope and we need the y-intercept. Well, if I look at it, I actually already have the y-intercept. The y-intercept is where it crosses the y-axis, and I can see that that is happening at 18. Now, you've got a choice to make here. You can use 18 to shrink the number down, or you can say 18,000 since you know that the number there, like the 18, represents $18,000. There is not one right way to do that. That's really a personal preference call. If you go with the 18, though, you need to remember when you're answering other questions or other parts of the problem that you have tinkered with the unit. Personally, I mean, I can do it either way, but I tend to get a little bit antsy that I'm not going to interpret it correctly. And so I'm just somebody that I'll say, listen, if I know it's supposed to be 18,000, I am going to use the 18,000. Now, in order to figure out the equation, then we need to have the slope. The slope requires that we know 2 points that are on the line, and they gave them to us. They gave 0, 18, and 10, 15. As before, I am going to use 0, 18,000 and 10, 15,000. You can use it either way. What I would say though is like you've got to be consistent. So what you can't do is you can't use 18,000 here and then use 18 and 15 here for your slope calculation, because it will throw it off. You'll have to make an adjustment somewhere else. So just be careful about that. All right, so now I can see the line tilts down, so I am going to have a negative slope. And we are going to do, we'll do 15,000 y2 minus 18,000 over 10 minus 0. I love zeros. If you haven't heard it yet, and some of you have, 0 is my favorite number. So this is negative 3,000 over 10, which is negative 300. And so my equation is y equals negative 300 x plus 18,000. Okay, first part of it's done. Now this is where it gets fun. Interpret. So we want to interpret the different numbers. What do they mean? What do they mean in the context of this problem? So for example, what does the slope mean? What does the negative 300 mean? So if you're doing this at home and you weren't in class to do it, pause the video and think about it and just make a little note in the margin of your notes or your notebook, on the bottom of your worksheet. Just kind of write down what you think it might be. Okay, so hopefully you have an idea. The fact that it's negative, what that means is that the balance is decreasing, because the slope is going down, and 300 is the amount of dollars that you're taking off the balance every month. So every month, your balance decreases by $300. You could explain that a bunch of different ways, and one of the ways I can tell when students are copying is if you and your buddies like all use exactly the same words, because there's a lot of different ways you could say this. So you could say it means the balance is going down by $300 each month. It could be $300 per month less in balance. There's just so many ways you could write it. But what it means is whatever you owe on that loan, you owe $300 less every month, because you're paying stuff off. Doesn't mean you're paying $300 a month, by the way. You're probably paying more than that because you're also paying interest on the loan. But your balance, the amount of money that you owe, is going down by $300 per month. The next question is, what does the y-intercept mean? So pause the video, give yourself a hot second to think about that, and then unpause it. Right? The y-intercept is right here. And in this case, again, a ton of different ways you could say the same thing. So you don't want to be using the exact same words as your neighbor. But it's the beginning amount of the loan. You could say the initial amount of the loan, the starting amount of the loan. You could say it is the amount of money that you owe at the beginning or at the time is taken out. What you don't want to tell me is the y-intercept is 0, 18,000. Okay, that's the location of the y-intercept, but it's not the meaning of it. So in this case, that point represents how much money you owe at the beginning. And that's the key part, is that at the beginning. But how you say that can be any number of those ways plus some. Then I think on the worksheet, I said interpret the intercept. So I kind of jumped down and said, like, interpret the x-intercept. So the x-intercept is over here. It looks like the x-intercept is 60. And that would represent, pause the video, think about what it represents now that we've talked about the y-intercept. Okay. The x-intercept represents the amount of time until you pay off your car. So it looks like 60 months. So that's what, 5 years? It's going to take you to pay off your $18,000 loan. And so that's what the x-intercept represents, how much time it will take you until you have zero balance or until you don't owe anything until you own the car. And then the last question is, what is the remaining balance after 36 payments? That, like, you can get an idea of what it is from the graph. Like, this would be 35, so 36 is going to be just a tiny bit over that. So, like, it looks like maybe if this is 6 and this is 9, like, it might be like about like halfway in between. If you need an estimate, you can do that. Like, it's about halfway between 6 and 9, which would be about $7,500. About, if you need it accurately done, then what you would do is you would take your equation and plug the 36 in for the x. Since it's not what we would call, that's really messy. Better. Negative 300 times 36 plus the 18,000, which I do not know off the top of my head, but I've got a bunch of calculators sitting here. So negative 300 times 36 plus 18,000. Whoops. Okay. 7,200. So, and I think I said when I said it a moment ago, I said about 7,500. So my estimate was okay. Estimating is great if you don't need to know the exact, or if you're answering like a multiple choice question and the answers aren't super close. You could look at that and say, oh, it's about 7,500. And then you look at your answer choices and it's possible that like it'll be close enough for you to pick the right answer choice, and then it can save you some time. Just depends on the context of the problem, what you're trying to do, and so forth. Okay. So this one is, this is part of a larger problem. I forgot how long this lesson was. It's a really long lesson. This has to do with like a prom venue. So if, like, let's just say you're on the prom committee and you've got to find the venue for the prom. And so you're looking at a place called the Lakeside Inn, and you have this information, like if 100 students go to prom, it's going to cost you $1,500. If 125 students go, it's going to cost you $1,800, and so forth. And so what we're looking for here is an equation that models what this data is. And this would be a linear relationship. Now, in real life, you're probably not going to need to write an equation for it because they'll just tell you what the number is, but it is actually a linear relationship. So in order to write the equation of the line, we need to find 2 points. And I am going to pick these 2 points because they have the smallest numbers. You can pick any 2 points. So you can pick the first 2 points, the last 2 points, the first and the last point, and any combination of points in between. You could pick the 125 and the 175, or the 125. I don't care what you pick. You just got to pick 2 points, okay? And just stick with it, any 2 points. But because I prefer making my life easier, I will pick the smaller points. And then I'm going to subtract them in such a way. So I'm going to do y2 minus y1. I'm going to subtract them in such a way that I can avoid the negatives. And this will be 125 minus 100. So 1,800 minus 1,500 is 300. And 125 minus 100 is 25. And I think that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 12. Okay, so the slope is 12. Yay. And now I need the y-intercept. So to do the y-intercept, I like to use the plug in a point, like borrow a point. So we've got y equals mx plus b. And I'm going to borrow the smallest point I have there, because why would I use bigger numbers if I can avoid it? So in my smallest point, my y value is 1500. I just found out that my slope was 12. The x value for that point is 100, and what I'm looking for is b. 12 times 100 is 1200. Don't overthink it. And then we'll subtract 1200 from both sides. And we get b is equal to 300. And so my equation that models this is y equals 12x plus 300. And that's about the amount of time it should take you, give or take. I'm getting a little bit slowed down because I'm writing it with a mouse, and that's really inefficient. So you should be able to write faster than me if you're using a pencil. But I'm also really comfortable with this. I've done problems like this a bajillion times. So I don't even think about what I need to do it. I just know what I'm looking for. And that's probably going to slow you down. But it took me less than 4 minutes. If it takes you more than, say, 8 or 9 minutes to do this problem, it's taking you too long. And it becomes an issue if you're just not sure what to do, not that it's taking you too long to do it. So you shouldn't be spending like much more time on it than that. Now, the next slide, we're going to interpret this. Like, what does the 12 mean? What does the 300 mean in the context of this problem? So y equals 12x plus 300. Oh, whoops. I have like stuff on there. I had no idea that was there. So what did we have? Y equals 12x plus 300. Okay. So this is asking us to compare. So we have 2 prom venues charge a rental fee plus a fee per student. And like the rental fee is like for the use of the facility, even if you have like 0 kids come. Okay, so it's like what you're paying to like have that room. And then they will charge you a certain amount per student to cover the cost of like food, wear and tear on the facilities, like bathroom supplies, like whatever they need to charge for that. So the table shows, oh, I didn't put the table on there. Oh, that's because we already did it. It shows the number of students at Lakeside Inn, the total cost in Y dollars for X students at Sunset Resort is represented by Y equals 10x plus 16 for Sunview. I think I wrote on your notes Sunset Resort, so I apologize for that, that it doesn't match. Which venue charges the greater rental fee, and how many students must attend for the costs to be the same? So we need to look at like which part of this is the rental fee. Keep in mind, like the rental fee is a flat fee. It's what you pay even if 0 students attend. So if I were to take 0 and plug it in for the X, like we're not going to have any students come. 12 times 0 is 0. 0 plus 300 is 300. So the rental fee for the Lakeside Inn is $300. Okay, that's what you're paying to rent the facility. You can do the same thing here with the Sunview Resort. If no students attend, what are you left with? $600. That's the rental fee for the facility. Now, Sunview Resort is going to charge you more for the facility, but they're going to charge you less per student. And so at some point, you're going to have this like kind of crossover on which one of those is the cheaper method. There's a option. There's a bunch of ways that you can do this, but one way is to look at the 2 costs okay, which are these two figures here. Total cost is 10x plus 600. Total cost is 12x plus 300. And you're asked, when will those two costs be the same? And so you could set that up by saying, when does 10x plus 600 equal 12x plus 300? Like, when does that happen? Let's go ahead and subtract the 10x from both sides. And we get like 600 equals 2x plus 300. Subtract the 300 from both sides. And I'm going to have to, I don't know where I'm going to do this. I'm out of space. 300 equals 2x. I'm going to go up to the top right. Okay, so if you need to know where on the screen to look. So 300 is equal to 2x. Divide both sides by 2. That's a 2. And we end up with 150 is equal to x. So if 150 students attend the prom, then both of those venues would be the same cost. If you have like more than 150, Sunview Resort is going to be the cheaper option. If you have fewer than 150, Lakeside Inn is going to be the better option. You can also solve that by graphing both of the lines. So if you're wondering, well, that was a lot of work, Miss Taylor, I don't know if I could do that. You can put those both in Desmos. You can put y equals 10x plus 600 and y equals 12x plus 300. You can put them both into Desmos and look at the graphs and see where they intersect, and you could get the 150 that way as well. So remember, I'm not looking, I was just telling somebody about the tower activity that we did, at least the year that I'm recording this, we did a tower activity, and the number of students that said, well, I can't figure out what you want me to do. I want you to be creative. I want you to be problem solvers. And that doesn't mean that you always have to do the problems the same way. So if you think you can figure out another way to do it, that's not photomathing. Okay. That's not solving a problem. That's copying a solution. But if you think like, well, what if I graphed it? I think I could get the answer that way. Try it and see how it goes. All right, last topic in this, and I know this video is getting very long. This is actually the shorter video. Last year's video was going to be longer. Finding line of best fit. So data do not always show an exact linear relationship. Now, it's something like the prom venue. It probably is exactly a linear relationship. But if you're like measuring stuff, like we're going to look at one where like you're measuring like the length of a bone, that data is not going to be as cut and dry. So what you often see with like data, like actual data that you're measuring, is that it looks sort of like a line, but not quite. So when the data in a scatter plot show an approximately linear relationship, like that looks like it's liney-ish, you can model the data with something called a line of best fit. So a line of best fit would be something like that, okay? The line of best fit is the line that goes through it comes as close to as many of the points as possible. It doesn't actually have to go through any of the points. It probably will go through one or two of the points, but it doesn't have to. It just comes as close as possible to as many of the points as possible. So when you're looking at this illustration, if your data is kind of scattered around, my line of best fit, it's like under some of those points and it's above others of the points, and maybe it might go through like this point and this point here, but it doesn't have to. So what we do with like real life data, if it seems like it's linear but it doesn't look quite right, is we will actually find the equation of something called the line of best fit. It's called a regression equation. Okay, I did what I tried so hard not to do on the last video. I managed to do it. I managed to kick myself off of the slide. So I had to, so there's probably a break. I had to actually stop the slideshow and kick myself back a slide. So yeah, lost my train of thought. So with the line of best fit, like I actually don't remember what slide I was on when I said it, but I had to do this by hand. We're going to use Desmos to do it. Desmos will actually do the line of best fit for you. And there's a demo that I've got that I might post somewhere, but I'm embedding the demo into this lesson. So what I'm going to ask you to do if you're watching this at home is, if you have like another device that you can play this video on, like you're playing it on your phone, grab your laptop and log into Desmos and do it with me. If you can't, watch the demonstration and then like make some notes and then try to do it on your own, because the only way you're going to learn how to do this is by practicing it. So, so the table shows femur lengths in centimeters and heights in centimeters of several people. Your femur is your thigh bone. And so what they did was they measured people's thigh bones and then they measured their overall height. And it kind of makes sense that like the longer the femur, the taller the person probably is. But we don't know if that's going to be a perfectly linear relationship. We kind of have an idea, like, you know, if your thigh is like a long bone in your body, probably you're taller. If it's shorter or smaller, like you'll be shorter. So what we're going to do is plot these points. So right here, you're going to have to like look at the screen, see where I'm circling. There's like a plus sign, and it's going to give us the option to add a table. And you'll notice it says X1, Y1. Now the X1 and the Y1, the ones, are just telling you this is table number 1. If you were to go down to the next line and do another table, it would come up X2, Y2, and it would be telling you table number 2. Keep that in mind, because when we do the regression, you're going to need to put that number in there because you need to tell Desmos which table you want it to look at. So what we do here is we're just going to straight up copy that table. As I am copying it, Desmos is actually going to plot the points. And it's so much fun to look at this because you can't see anything. You can't see anything. So I'm just going to keep going down this table here. 162. We have 41 and 174, 30 and 141, and we'll deal with the issue that we have there in a second. 34 and 151, 47 and 185. And I do want you to practice this on your laptop and not on your phone, because as good as the Desmos app is, you're going to need to know how to do it on the keyboard, and it's faster. Okay, now we have the problem here is that we got this awesome table and we can't see any of the points. In the lower left, there is this little magnifying glass with a plus sign on it that says Zoom Fit. And what that does is it's going to take our Desmos window and zoom it however it needs to be zoomed to find the points that we plotted. So you don't have to like zoom in, zoom out, use your scroll wheel. Like you don't have to do that. Just click Zoom Fit and nothing will happen. There we go. And it will zoom the window so that you can see where those points are. And if you look at where, you know, my window is, I got like 150, 200, I'm over here at like 30, 40. Now, take a look at that data, because that data looks linear, but not quite. It's not a perfect, like in a straight line, like perfect linear data, but it's definitely a line. So we would call this a linear relationship. We would say that this is a linear data, and we understand that in the real world, data isn't perfect, because like this, in this case, it's like the human body. Okay. So like we're all different. And so we don't like follow this like perfect thing, you know, going on. So now we were looking for that line of best fit. We know that lines take the form of the equation y equals mx plus b. If I type that in, I get some kind of scary stuff. It says like add slider, MB all, don't click anything. And then over here on the left, I have this exclamation point, which is saying there's too many variables, try defining MRB. Basically, it doesn't know what we want it to do. So to do a regression, there's going to be 2 changes that you need to make, okay? One is, instead of using an equal sign, you are going to use a tilde. All right. Now on your laptop, that should be right to the left of the number 1. So go find the number 1 and then look to the left and you'll hit shift and then that will give you your tilde. That's going to tell Desmos that we want to do a regression. Okay. Now the exclamation point is still there, but it says y may not be used as a regression parameter. Try using a list. So what that's telling us is that Desmos knows that we want to do a regression. It knows we want line of best fit. What it does not know is what numbers it's supposed to use. To fix that, I'm going to move my cursor over the y and I'm just going to type in the number 1. And what that means is like it's telling Desmos use the numbers in table 1. If you mess this up and you've got like table 2, you would just put a 2 there. Just like use table 2. And then I've got to come over here to the x because it's probably giving me the same error here. Like x may not be used as a regression parameter. I'm going to type just the 1. You don't have to do anything for the subscript. And now Desmos is like, oh, I know what you want me to do. You want me to find a regression and you want me to use the data in that table to find the regression. That's because Desmos, like you could have more than one table. And so it's expecting you to tell it which table. Now check it out. We've got some statistics. We are going to ignore the statistics. What I am interested in is the M and the B. Now check out the line of best fit. Kind of look at it for a little bit. It does go through some of the points. It looks like it goes through this point over here on the right, and it goes through a point right there, but it doesn't go through all the points, okay? It's like below some, it's above some. Remember, the line of best fit is the line that comes as close to as many points as possible. Now, if you were asked to write the equation of this particular line, you would use the M and the B provided there, and we would say y is equal to, I'm going to round that to 2.6x, and then that is 64.996. I'm going to go ahead and round that up to 65. And then it does ask us to do something. Now, I'll do this. There's a practice problem coming up, and it says like you've got to answer the question, and I'm not going to require you to do that. I just want a screenshot of you doing the regression on Desmos. It says estimate the height of a person whose femur is 37 centimeters long. Well, femur length was the x value, so that means we're going to take that 35 and plug it in for the x. And I don't know what that is off the top of my head, but I have a calculator. So 2.6 times 35 plus 65. And I got 156. Now, this kind of thing does come in handy if you've been to a doctor, especially with like little kids. There's like a certain amount of like growth or height that is expected for a male or female of a particular age. Okay, and so and it has to do with like basically how close to that line are you. If a baby, particularly baby or a very young child, starts to fall outside of it, so you might see something where you've got, let me change it to the highlighter, where there might be like a band on either side of this, like what, and this might have like age instead of femur length, but like for an age, and there'll be like this band. So they'll have like a line of best fit for the data and then a band around it. And anything inside that band is considered normal and healthy. But if there's a child that starts to fall way out of it, so they're, 45 years old, but like let's say they're 4 years old and their expected height is, and then they're way below it, that just alerts a doctor to know that there might be something else going on here. Maybe we need to run some tests. We need to find out why this child is not growing at the rate that we expect. So that gives you an idea of like where something like this might be used, why you might want a line of best fit, and then kind of like a band of best fit that is a way of graphically representing what might be considered normal. All right. Oh, I actually have to stop the recording again because of how I messed it up. Okay, so the last piece of this, and this video is going to be a little bit shorter than the one I did last year, but only by about 5 minutes. So the table shows the humerus length, that's a bone in your arm, and heights in centimeters of several females. Okay, so you got your X and your Y. I have like skip on there. It says use technology to find an equation for the line of best fit. Estimate the height of a female whose humerus is 40 centimeters long. So even if you're at home, if you'd like a grade for this, now generally if you're absent, I will excuse you from a classwork assignment. But if you were absent and you'd like to do this, like, hey, I get this, I want to get my grade for it, awesome. What you're going to do is do this on your computer, take a screenshot, and then write your name across the screenshot. So you're going to do something like this. You're going to do like Miss Taylor, like right across your screenshot. And what that does is it prevents somebody else from stealing your screenshot and submitting it as their own. And then you can go to the questions and discussions channel in Teams. Now, if you're doing this after class, I've probably already graded the ones that were submitted in class. So make sure that you tag me in it, in your photo, and say, Miss Taylor, I wasn't in class, but I am submitting this for a grade. And what I might do is if you, all I want to see is a screenshot that you do the linear regression. If you want to use the equation and do the estimating, I'll maybe throw in an extra point for you. Okay. All right. So that's this entire lesson. I know it was a long lesson. Thank you for hanging with, and I will see you hopefully in class soon.